us today will receive a copy of that webinar when we finish it. And as well, those that have signed up that weren't able to join us today will get a link to that copy also. We will keep everyone muted for the duration of the webinar, but then at the end, we'll go through the chat window and also open up the mics. You're welcome to turn on your mic at that point and ask some verbal questions to either Jeff or to Brent. Again, appreciate your time today. I'm going to turn it over to Jeff Smith and we'll get this thing started. Thank you all.
Thanks a bunch, York, and thank you everybody for joining our webinar today. My name is Jeff Smith, and I work with Trimble Water, and I'm the Southeastern Regional Manager for Trimble Water, and I'm based out of Tampa, Florida. Been with Trimble for about 20 years, and I'm looking forward to presenting our solution for Trimble Unity remote monitoring with Cityworks. Also on the phone with us today, or the webinar, is Brent Wilson. Brent is the Vice President of Sales for Cityworks. He's based out of Dallas, Texas, and has been with Cityworks, I believe, just as long as I've been with Trimble, for about 20 years. So the format of the webinar today is we're going to do a little bit of PowerPoint and a little bit of a demonstration, and we're going to review what the solution has to offer. So I'm going to start off with framing up Trimble Water, Cityworks, and how it fits into the Trimble organization. So Cityworks and Trimble Water are part of the Trimble Utilities and Public Administration business. And this has vertical markets serving water, district heating and cooling, local government, natural gas, electricity, and communications. And within that is our solution that we're going to present today, which is a mashup of Trimble Water, the Trimble Unity software platform that we're going to be presenting, and Cityworks. So to start, I want to go through what remote monitoring is, what we do, and how it can provide benefits to you. We have lots of different equipment that can help with your remote monitoring needs. But to start, just know that Trimble has around 20 plus different types of data collection devices, data logging devices that can provide you information so you can monitor the performance of your assets in real time. And we do that through a collection of wireless enabled data loggers. They're all built with 4G LTE modems built into it. They're very rugged. They're all battery powered. So they're very mobile. We do lots of work so that we can extend the life of our battery in these remote monitors so that you're not always going out into the field replacing batteries. They can provide a variety of different types of data collection activities. We have data collectors that I'll review that are what we call single channel monitors and then multi-channel monitors. And what that means is that a single device can monitor multiple different sensors at a single time. Or if it's a purpose-built recorder, it will just monitor one thing at a time. All of the data flows from the field into the Trimble Unity Cloud platform. And inside of the Trimble Unity Cloud platform, that we're able to do smart sampling, alarming, and even creating Cityworks jobs so that you can react and respond to problems that are happening out in the field. Trimble Water data collection portfolio covers the entire water cycle, whether that's clean water, wastewater, as well as stormwater. So we have devices and that can meet any application, any type of data collection application that you need. So we're not just limited to a single point solution, say just for monitoring pressure or just for monitoring water level or monitoring flow inside of a manhole, inside of a sewer system. We have data collection devices that can meet all of your needs for water, wastewater, and storm. So how does the system work? So on this page, you're looking at our data collection devices on the left in certain applications. These are just representative applications, but what they are is our Trimble data collection, our Trimble Telog data collection devices that are in the field. Each one of these sites or each one of these data collectors can be programmed and configured to collect data to meet your need. And Once information is collected, it is sent via cellular wireless, and it's uploaded into Trimble Unity's cloud all through the cellular network. Now, Trimble Unity is the platform that you're going to view the data, be able to interact and control the data loggers out in the field, and be able to manipulate the data all through a website. And so Trimble Unity is a GIS-centric cloud-hosted solution. With Cityworks, once the data is inside of Trimble Unity through an API that Cityworks and Trimble has created, and it's a product that we maintain, it turns alarms and notifications into real activities that you can respond to through Cityworks. All data that's collected within Trimble Unity can also interact with your SCADA. So if, for example, you're monitoring pressure or water levels or flow or anything that we're collecting that's available and inside of Trimble Unity, through an API, it can also communicate with your SCADA. And then in a full rollout, it has the ability to not only communicate with SCADA, but also with Cityworks all through the Trimble Unity platform. So this is done through a collection of APIs. So to review, now Trimble has approximately 20 to 25 different types of battery-powered, rugged, wireless data loggers. I'm not going to review each one, but I am going to go over the most popular data collectors that can pretty much meet any type of need that you have at your water or wastewater or stormwater utility. So first is our fire hydrant mounted hydrant pressure recorders. The name of this product is our HPR 32A and 32IA. Anytime that in any of our models that you see the designation I stands for impulse. So all of our pressure recorders have the ability to monitor standard pressure, but also impulse pressure. And impulse pressures are how that we're able to monitor for water hammers and transients and events that cause leaks and break pipes. So we have an HPR 32A, which means it's a standard pressure data logger, and then we have our 32IA, which can catch impulses. And here's some pictures of the hydrant mounted pressure recorder that we have. So on the right, you can see that the hydrant pressure recorder is the yellow device that's on the nozzle of the fire hydrant. It's built to look very much like part of the fire hydrant. It can be bought in different colors, and we even have security locks so that no one can mess with it and possibly steal it. But the hydrant pressure recorder is very versatile. You can mount it, for example, the picture on the left, to monitor a pressure complaint. You can mount it directly to a hose spigot on the side of the house to monitor pressure, or really any place where you have a 1/4-inch MPT fitting, a hydrant pressure recorder can be connected. It's meant to be above ground. The hydrant pressure recorder is. It's not meant to be put into a vault or anything that's flooded. So it's made to be put above ground. And the answer for being able to do underground monitoring, to be able to monitor pressure with one of our devices, is our PR32 and PR32IA. These are close relatives of the HPR, but they are made to be connected directly to the pipe and can be mounted into a vault, underground or above ground. The PR32 monitors different types of pressure, not just pressure inside of the pipe, but we can also use it to monitor pressure for measuring water levels. So here are some examples of the PR32A and PR32IA. So one, it can monitor water levels, whether this is inside of a tank, inside of an aquifer, a pond as represented on the left, or the PR32 can be used to monitor pressure in a clean water or wastewater network as shown on the picture to the right. And once again, the PR32, just like the HPR, the hydrant pressure recorder, can monitor for impulses and water hammers. The difference between the HPR and the PR32 as it's related to pressure monitoring is that, of course, that hydrant pressure recorder is built to be mounted on the side of a hydrant, but the PR32 can be mounted pretty much anywhere, but it's mainly made to be more of a fixed or a permanent installation. However, it's battery powered and it has a very easy way to connect it to your water network through a 1/4-inch MPT fitting. Another close relative to the PR32 is our RU32 and our RU32 IMA. Now, this is what we call a multi-channel recorder. This has the ability to be able to monitor not just pressure, but maybe two channels of pressure. For example, for doing PRV monitoring, you might want to monitor the inlet and outlet pressure with a single device. Our RU32 has up to 8 different channels of inputs that you can use to be able to monitor many different types of sensors at a single site. So an example of this is water level monitoring, PRV monitoring. As I mentioned before, you can monitor inlet and outlet pressure. We have some customers that for monitoring inlet and outlet pressure that is inside of a valve. They can also hook in, say, a water level monitor or a float switch to be able to tell if there's water filling up inside of a valve and if it stays that way for a while. So an RU32 has many different applications. So if you have any applications where you need to monitor multiple different things at a single site, the RU32 is the product for you. Trimble Water also has what we call our insertion flow meter. This is a new product of ours, and it's made to work in tandem with the RU32. So at a PRV site, you can monitor inlet and outlet pressure, but we also have unique channels that you can connect meters to, such as our insertion flow meter. And here are some pictures of it being installed for you. So our IFM is really part of our non-revenue water product portfolio. It helps with flow monitoring, leak detection. It gives you flow rates, flow volumes, can pick up reversals of flow and be able to pick up very low flow type situations like at night. All of this can help you be able to isolate where or be able to determine if there's leakage in a certain area. So that is another example of how the RU32 is very flexible. You can connect many different sensors to it. Also following on our non-revenue water portfolio is our LDR32, which stands for our leak detection recorder. It's an acoustic leak detection recorder that can pick up and be able to identify where leaks are on ductile iron and PVC pipes or concrete. Pretty much any type of pipe that's in your network, we have the ability to be able to isolate and correlate where leak locations are. A very unique part of the LDR32 is that it correlates the location of where a leak is in tandem with your GIS. So it is a GIS-based leak detection solution. And this product, once again, is made to be able to be installed throughout your network to be able to identify where leaks are and be able to present the location in your GIS on a map so that you can accurately go navigate to where that leak possibly is found. So once again, the leak detection recorders are built to work in tandem with your GIS. And here are some pictures of the LDR32 in action. So there's 2 different types of leak sensors that we have. We have what we call our accelerometer, which is made for listening for leaks on metal pipes like ductile iron. And then over here to the right on this fire hydrant and on this fire hydrant meter, we have the ability to listen for leaks on PVC water networks. So whether it's plastic or whether it is ductile iron or metallic, the LDR32 can help you be able to identify where leaks are. We have our RG32. This is our rain gauge and very popular product. It's built to be able to monitor rainfall. So if you have any type of precision rainfall monitoring applications, the RG32 is the product for you. Very easy to install. It comes with a rainfall bucket sensor, a tipping bucket rain gauge sensor, and it has the ability to provide that information into Trimble Unity. And these are pictures of just some of our customers installing the RG32. Each one of these are shown being mounted on a post, but our rain gauges can be installed on the ground, on the roof of the building, or you can do something nice like what these customers have done and mount it onto a pole. Then we have our RU35. This is our most rugged data collector. It's made for manhole applications. So it's very waterproof. It's made to be mounted into a terrible environment and be able to last for a very long time. It can be connected to a wide range of different wastewater flow sensors. Pretty much any wastewater flow meter that's on the market, the RU35 can communicate with it, as well as a variety of different types of water level sensors, whether it's ultrasonic or any other type of non-contact water level monitor or sensor. We can also be connected to float switches, but it is a product that is made to be mounted inside of a manhole and be able to send that information to Trimble Unity in real time. And these are just some pictures of the RU35 connected to what we call a Raven Eye, as well as a flow wave area velocity meter. But once again, the RU35 is not married to any one particular sensor. We can work with all of the major flow meters that are on the market. The RS-33 is our only AC powered data collection device. It's really built for doing pump station and lift station monitoring, and so it can be hooked to be able to monitor up to 30 different channels of information. So if you want to be able to monitor pump run times, energy usage, pressure, flow, these particular devices are made to be mounted inside of a pump station or just outside of one and be able to communicate with all of the sensors and electronics that are gathering data inside of your pump station or lift station. But once again, the RS-33 is our only AC powered unit. Now, it does have a battery backup, and just in case power is lost, the unit will still operate, gather data, power the devices that need power, and be able to send that information back to the cloud. So I'm going to go over and show you Trimble Unity remote monitoring software to get an idea of what the package looks like. So let me skip to Trimble Unity. And York, will you confirm that you can see my screen?
Yes, we sure can. Go right ahead.
Okay, great. So this is Trimble Unity remote monitoring. This is our cloud application. It's simply accessible on through a web page. You log in with your username and password. It's a very secure system, and we have documentation to show you what type of security measures that we take with this. But you have access to our Trimble Unity remote monitoring website, and you type in your organization's name and then your username and password, and then you're presented with a map showing you the location of all of your monitoring devices. So you can see that it has a map-based front end, and it shows me the location of where all of my monitoring sites are. And then over here on the left, it's showing me a list of where all of these sites are located. So if I want to be able to access, for example, this particular hydrant pressure recorder, I simply click on it. It presents me with a map of where it's located. And then I can simply click view the default report to be able to see the details of the pressure data that's coming in. What we're looking at is a default report that's been set up to show me the last 3 days of pressure data. Now, if this was a PRV site, I would be looking at multiple different types of pressure. If this was a lift station or a pump station, I would possibly see up to 30 different types of measurements that are coming in here. But this is a hydrant pressure recorder. That's a single channel recorder. And it's actually just showing me the minimum, maximum, and average pressure for this 3-day period. It's very easy to be able to navigate to a precise date and time, but the default report that we have set up for this demo is 3 days. But if I wanted to go back and look at the data from September 1st until today, I would simply just click September 1st. We also have some easy tools where I can click this 1 day button and be able to say, show me the pressure data for the last day. And this shows me just the last 24 hours worth of information. Lots of easy ways to be able to really dig deep into the data and be able to see what you're looking at. I can also click on this view table, and this will show me all of the historical time series information that I'm looking at on the screen. So I can scroll up and down through this and be able to see what the minimum, maximum, and average PSIs were for this particular site. We also have the ability to view a summary. So if I click the summary button, it's going to give me a summary from September 13th at 1:20 p.m. to September 16th at 1:20 p.m. And it will automatically give me the minimum, maximum, and average pressures that have been that were gathered during that time period. It also gives you a nice little timestamp of exactly when the minimum was reached and exactly when the maximum was reached. Very useful for being able to troubleshoot problems. If I would like to export this data, if I hit the export button, this data can be downloaded to an Excel spreadsheet. So this is a cloud-based application. So once I run this export, it actually will just download to your local computer system download tray, and I can open it up in Excel. Now, also on the graph, this is a hydrant pressure recorder that has impulse capabilities enabled. So not only am I seeing, 3 days worth of data, I have some call outs here at the bottom that says that a pressure transient or a water hammer was experienced during a certain period of time. So as I just use my mouse over the graph, I can see just basic information about that particular water hammer. For example, the one that I'm hovering over right now tells me that there was a water hammer or an impulse that was experienced on September 14th at 6:56 a.m. I also have what's called a impulse or a transient view. So if I can look at all of the transients that have occurred at this particular site, and it gives you a nice clean list of each transient or water hammer that was experienced during this. We color code the transients and impulses based upon their severity. And you have complete control to be able to configure how the impulse is captured. But if I were to go to this major impulse that happened at this particular time, I would double click on it. And here's where it shows me, let me turn this off. This will show me the actual, so instead of looking at 3 days worth of information, whenever I double clicked on that particular unique transient event, it shows me 1 minute worth of data. This would be almost impossible to view if I was looking at a 24-hour period or a 3-day period. This is actually showing me 1 minute in time, and it can show me the transients that were happening before and after the alert happened. So very easy to be able to dig into this data and be able to see the entire life of a transient. So moving back to the main screen, I failed to mention that when you look at all of your sites, they're color-coded by their status. So a site that has a blue symbol represents an RTU, or one of our recorders, that is operating as expected, as normal. If we see that it's color-coded in red, that lets me know that that an alarm condition has been met. So what an alarm does is within Trimble Unity, you have the ability to notify people via text message and email whenever data goes outside of normal operating conditions. And you have full abilities to configure each site to meet those different conditions. And I'll show you that in a minute. But that's what the red sites represent. But you can know that if there is an alarm that has been created, that a person or a group of people have been alerted to this via text message and or email. Now, with Cityworks, we have the ability to not only for an end user or a group of people to get this text message or an alarm via email or text message, it can automatically create a work order or a service order directly into your Cityworks and assign it to a unique individual. So the alarming inside of Trimble Unity can be sent to an entire group, but a singular job inside of Cityworks can also be created. Now, with Cityworks, Unity has a direct connection with Cityworks. So if I want to be able to see Cityworks work orders, I can simply turn them on. I can turn on Cityworks inspections and be able to see where they're located as well. And this is a live view of what's happening inside of your Cityworks. So if I were trying to, if I was trying to look at this particular monitor that had an alarm, this one right here, I have the visibility to be able to see what work is being done in the area through what's happening in your Cityworks, and I have that ability. So having the ability to look at work orders and inspections in Cityworks can help you to determine what the cause of the problem may be. But it's also just nice to know where work is occurring in Cityworks at any moment in time. So if this particular device that has an alarm, we can create a work order and issue it to Cityworks, to a user inside of Cityworks for responding to that particular problem. So what Trimble Unity and our remote monitoring devices do for you is to be able to give you a very live, real-time look of how your assets and your network is performing. And whenever they're not performing up to the level of service that you would expect, you can issue a work order to Cityworks. So very integrated platform. So work orders can be issued automatically through an alarm that's set inside of Trimble Unity. Or you can manually be able to create a work order or any type of Cityworks job or template to be able to issue to somebody in the field. I'm going to turn the work orders and inspections off just for a moment and show you some other tools that we have. So this is showing me all of my different types of monitoring sites. Now, in this particular organization, they monitor water and wastewater. They have water and wastewater applications. But if I want to narrow down, let's just say I want to look at just my hydrant pressure recorders. I can clear those and just say, show me the hydrant pressure monitoring sites. And when I do that, it will filter the sites to just show me hydrant pressure. If I am want to look at lift stations and turn the hydrant pressures off, I can literally go over here to lift station, hit apply, and this will show me my lift station monitors. And if I want to look at the data of a lift station, I can simply click on it and be able to see the data. So this is a site called PS42 or Pump Station 42 on Ogden Road. It can tell me the battery status. So this lets me know that this has a good looking battery. It tells me whenever the last data call came in and when the next data call is scheduled to arrive. I can look at all of the historical alarms that happened at this particular lift station. I can drill down into it by double clicking on it. And then I can look at more data about this particular alarm that was found. Let me go back. So I'm going to turn back on my hydrant pressure recorders. Let me clear this and just go to hydrant pressure. Sorry, I'm not letting me go all the way up. So I'm just going to turn on my hydrant pressure recorders. And I want to show you another nice feature of being a GIS-centric type monitoring application. So if I zoom out a little bit, I can see where all of my hydrant pressure recorders are. But let's just say I had a problem in this area. So it's very easy to look at a single site, but with Trimble Unity, you have the ability to look at multiple sites. So I can do a geospatial selection and be able to look at this data. So if I select these, I can look at the measurements. So what this will do is whether I select a single device or if I select multiple devices and I'm trying to troubleshoot a problem, I'm able to stack multiple pressure monitors on top of one another so I can look at the time series data and see if there's any correlation between a problem with pressure. So each one of these is color-coded by its different site. For example, this color green represents the North High School pressure site. The purple represents the Episcopal Church pressure site. And this particular green one is the Aurora Avenue site. But very easy to be able to compare the data. And this helps you be able to troubleshoot what's happening in the field. I can also go here and hit my summary. And what it'll do is for those three sites, I can look at a summary for each one of them. So I can see the North High School pressure site had a minimum and maximum and average pressure of this, while the Episcopal Church had this. So very easy for you to be able to look and try to dig into the data to be able to see if there's any correlation of the problem. Now I'm showing this for a hydrant pressure recorder, but this could be for a variety of different applications. Maybe this is wastewater flow or level. And if I wanted to compare multiple sites, I would do it in the same exact way. I'm just showing the hydrant pressure recorder because it's very simple to show and be able to visualize here. But so it's very easy to be able to see multiple different sites. Now, because this is GIS-centric, we have a connection to your GIS. And not only can we show you, what I have shown on the screen here are water and wastewater network assets. And if I were to click on any one of these, if I were to click on it, it would show me the information. For example, this site right here I just selected. So this is a sewer tap. And if I were to click that particular sewer tap, it would bring up my live GIS data. Now, Trimble Unity can be connected to your GIS in a variety of different ways, a feature surface or a web service connection. But if a customer doesn't have that, we can simply make a static import of the geodatabase and be able to represent the data that way. But we always recommend the most live connection that you have access to with your GIS. Another nice feature of Trimble Unity and being GIS-centric and tied into Cityworks is the concept of a KPI. So we're able to gather lots of data out in the field. For example, for a hydrant, we're gathering minimum, maximum, and average pressures. Well, that data is visible directly inside of Trimble Unity. Trimble Unity hosts this data. So if you have this particular site and you've been gathering data there for 6 months or 2 years and 6 months or a single day, you're able to access and look at all of that data inside of Trimble Unity. But we have the concept of being able to configure a KPI or a key performance indicator. So where we can write, say, the daily average pressure for this particular site, we can write that directly to a feature, to say the hydrant feature class in your GIS. So not only would you be able to look at the hydrant and know that it's red, that it's red in color, it's made by American Darling, but you can also say this is the average daily pressure that has been monitored through Trimble Unity. So Unity can be configured to write this real-time data into your GIS. And why is that important? Not only does it give you situational awareness to all of your people out in the field that have mobile applications with Cityworks, but you're able to look at these key performance, these KPIs that are near real time. And once it's inside of your GIS, you can use the dashboard and reporting capabilities of Esri and things like that so that you can be able to present that data. So very powerful tool, very integrated with GIS. These KPIs we have a collection of KPIs that are pre-built, that are ready to go for pressure, for wastewater flow, and other wastewater applications. So we can write this data from our monitoring devices directly into GIS. Now, for the site, being a remote monitoring application, we have the ability to, without having to visit the site, I'm obviously able to look at the data, but I can also go to the actual device itself by clicking this button called RTU. And I can see, if I click on the RTU, this gives me information about that precise piece of hardware that was purchased and installed. It lets me know that this is an HPR32IA. It tells me when it was added to this particular site. It can tell me when it was registered to the network, to Trimble Unity. It can tell me call information. But also, if I scroll down through here, I can look at what its call schedule is. For example, how often I want the data to be sent to Trimble Unity's cloud. I can see how each one of the sensors or channels are configured, how each one of the alarms are configured, and how the impulse capabilities are configured. So I can see here just through a click of a button that this particular site, called the Aurora site, it's set up to have an alarm that gets triggered whenever the pressure drops below 51 PSI, and a higher happens whenever it gets above 117 PSI. Now, if I want to change that, you have the ability to do it remotely. Even if this site is 20 miles away from your office, I can hit edit. And this brings me to the edit screen, to where I can configure how that particular site and that piece of hardware should behave. So here's where I can change the call schedule. So right now it's set up to actually call every 4 hours, or I can set it to call at a precise time of the day. I'm not going to make any changes on that. I can look at this particular sensor. So there's one sensor in this hydrant pressure recorder, and I have it tagged to be able to record minimum, maximum, and average pressures. I can set how quick I want the sampling to occur. So right now it's set to sample 4 times per second. But since this is our impulse model, I have the ability to set this to be able to sample all the way up to 256 times per second. And then I can gather all of that information and set a recording interval. And this gives me a very easy way to be able to gather and how I want all of this data to be averaged and gathered together. So these are the way that you can set the recording sample rate and the recording interval. There's some other tools that can get into where how you need to actually configure the sensor. I won't get into that, but it does have some further capabilities to be able to really fine tune this particular pressure logger to be able to capture the data that you need. Underneath the alarm configuration, this is where I can simply change, instead of 51 PSI, maybe I want to change it to 30 PSI or whatever meets your needs. So if you start getting alarmed and it doesn't seem right, you can make a change to the configuration remotely without actually having to go to the field. I can also create who gets notified. So we have the concept of notification groups. These are people, the people or group of people that would get an alarm, a text message, or an email if this particular alarming condition were to happen. We're also able to configure if a Cityworks work order inspection needs to get associated with this, and this is all configured through the site. So you have full capabilities to do this within Trimble Unity without actually having to bring the recorder back into the office or do work out in the field. This can all happen remotely. And then underneath our, since this is an impulse monitor, I can enable pulse detection, and this is where I can set how I want the water hammers and transients to be captured and be able to be flagged. So this is set to be able to recognize a pressure difference in a certain time interval of 19 PSI. But this is very easily to be changed to 50 or whatever pressure details that you consider as an impulse. So you have a lot of capabilities there to be able to configure this. Now I'm showing this for a hydrant pressure recorder just for simplicity, but this is the exact same tool that you would use if you were trying to configure how a pump station monitor behaves or a insertion flow meter or a PRV site. It's just more data, and there's different ways that you can configure that. Through this particular system tool, there's lots of ways for you to be able to monitor but be able to create user groups and permission policies, who can see what data, who can configure recorders, lots of different ways to do that. You can create notification groups, very simple to do that. These are my existing notification groups, but if I want to edit this and be able to add a new user into the North District group, I can say new recipient and type the person's name and their email address. And save that. So what would happen is the next time that alarm occurs on that particular group, I'll get an email with a notification. But this is also how you would set up Cityworks to be able to get a service order or work order. Another tool that we have is some general system settings. Let me go back. So we have our system settings. Now, this is where that you would be able to connect Trimble Unity to Cityworks. So we have different ways to be able to connect directly to the Cityworks API, be able to assign what the server name is, the username, password, lots of different ways so that you can make this connection. And then also, this is where it says KPIs and GIS update settings. This is where you can configure each one of these different sites to be able to write that data, these KPIs that are being gathered in the field. So we have a very easy wizard that takes you through this so that you can configure the KPI so that not only do you see all of the historical data inside of Trimble Unity, but you can write that data to unique feature classes inside of your GIS. So that is really the 10,000 foot view of Trimble Unity and its basic, the capabilities of how it works with Cityworks. I'm going to move this back to my presentation, and I'm going to flip this over to Brent Wilson, the VP of Sales for Cityworks, and he's going to take you through some additional information about our integration and how we work together. So Brent, I'm gonna push it over to you.
Yeah, thanks, Jeff. Yeah, so I don't know how many of you have heard of Cityworks in the past, but Cityworks were an asset management application. And you may be thinking, well, where does Trimble tie into this asset management, and why is Cityworks part of it? Last October, Trimble acquired Cityworks, and the big reason for why they acquired Cityworks was that they were looking for a way to make their IoT not just, the intelligence of the IoT, but make it actionable. And so the system of action is something that they were looking for, and how they could do that. And so, of course, we had been partners with them for a long time. We started having discussions, and kind of the rest is history. But what we're looking to do is integrate this real-time IoT that Jeff has been talking about with our intelligent asset management system for all of wastewater and water utilities. Now, Trimble supports every phase of a life cycle of an asset. So it doesn't really matter what stage you're in. There is a function within Trimble that we have tied all together to help you build, from planning and design, engineering and construction, operations and maintenance, and analysis and optimization. So every phase of this life cycle, the Trimble organization now has products that can help you build around that, and of course using the IoT that Jeff has so greatly described over the last few minutes. We want to help our industry with the challenges and ways to solve these challenges. So, like aging water infrastructure, we all have seen the report card of the U.S. Aging water infrastructure, and that we have these pipes that are deteriorating at a rapid rate, and we don't have the money to fix all of them. And so we want to help solve some of these solutions with applications like the IoT and the hardware that Jeff has been talking about, that monitors these pipes and that monitors these manholes and so on and so forth, and then be able to have real-time data to be able to go out and fix problems, maybe before something breaks, like if you're getting water hammers like he was discussing. Maybe there is an issue that we can fix before a pipe burst or before there is some type of deterioration within the system. And so we are looking at ways to help you solve those challenges, and using our asset management combined with the IoT of Trimble hardware, we really feel like we have a unique solution in the marketplace that can help you solve these challenges. So the system of action, what is it? How does it work? And what's going to happen? So we're really, it's one company, Trimble, offering this solution stack of IoT. Okay, so the Trimble Telog remote monitoring application, is going to pick up some sensor signals that's going to tell the Trimble Unity product that's already built in, hey, here's the information. Now, Unity being the software piece that's tied to the Telog hardware piece, right? And then in the past, what would happen is someone was either monitoring that, or they would get an email that says, hey, there's an issue here. And then that person would then go to their work order system or go to their asset management system and create a work activity. Or maybe they have pen and paper and they write down that, hey, I need to go look at this out in the field. But there was really no way other than that to actually put it in the hands of the workers. And so with Cityworks, what would happen is Unity remote monitoring would then be able to pass off that information to Cityworks, the asset management system of record, and actually make it actionable. So this intelligent data that's coming from the Telog remote monitoring in Unity is now actionable out in the field to go out and track the work activity. How much money are you spending? What are you doing and who's doing it? When was the last time we were here? Has this happened before in the past, and how can we resolve this issue, and maybe it's replacing this asset before deterioration is caused any further. And then that actually can be passed off to operational insights or Esri analytics to be able to start doing risk strategies and prioritization within the whole overall application. So the scope of the solution, sorry, I need to advance my slide here. The scope of the solution is basically the integration of the IoT and Unity, the Telog IoT and Unity with the Cityworks AMS and Esri GIS, okay? With the application, you can do everything from have the IoT out in the field, triggering off work activities, have the work activities help you prioritize your capital improvement or help you prioritize immediate work that needs to happen right now because of the fact that the IoT is censoring something that's really important that needs to happen immediately, as well as giving some futuristic, consequence of failure, probability of failure using Cityworks operational insights. So real-time asset management and performance alarming. This is the first piece, which was already explained in detail by Jeff. These two applications, Telog and Unity Remote Monitoring, is going to be the first phase of getting this going within this overall system of action that we have. It's not a system of action without having the pieces that are saying, hey, this is the real-time alarms that are coming in. Then moving on to potentially a field investigation and repair. So Cityworks Respond, or our native mobile apps out in the field, can help you quickly and easily be able to handle these work activities, add in the cost of how much money you are spending while you're out there, and of course tracking all of the conditions and the full life cycle, the full asset life cycle of the asset that you're working on. And so once again, we have Cityworks Respond and our native mobile apps that can work with this IoT application. You also have your Esri's real-time insights. And so there are analysis that can be done with Esri's operational dashboard or the Esri Insights applications to give you a look into the analysis that you need to do and be a location aware, have data visualization. All of these tools for asset performance are right at your fingertips using the Esri, Cityworks, and Trimble packages that you see here. And then, of course, last but not least, would be your risk strategy and prioritization. So Cityworks has a tool called Operational Insights, and this really helps you with your consequence of failure, your probability of failure, and giving you a business risk exposure on that asset. And so it will help you take different data, not only the IoT, but also your age of your asset, the material of the asset, and all of your history from work orders and inspections and things that have happened. And then that can then take all of that information and give you a number, and it's called the BRE, the business risk exposure. And that number then lets you know kind of where that asset sits, not only in the overall organization, but where it sits comparatively to other assets within your organization. So if you have an asset that has a very high BRE and it's sitting in front of a hospital, well, then you probably need to go and replace that asset, because you definitely don't want that pipe to fail sitting right in front of that hospital. At the same time, if that BRE is really high, but it's sitting in front of a house out in maybe the county, well, if someone went without water for 6 hours, they would probably be okay if they're on a dead-end road out in the middle of the county versus the hospital, right? So it helps you start prioritizing where you're going to spend your money. So why Trimble Unity, Remote Monitoring, Cityworks, and Esri? What makes this such a powerful combination? Well, basically, you're gaining these real-time assets, okay? But you're going to be able to integrate all these powerful products and create a unique and comprehensive digital platform with real-time asset intelligence, workflows, analytics. Everything is there to help you gain better insights into your asset performance. It's really going to help you shift your focus from reactive to proactive and start getting into more of a proactive maintenance practice. You can help reduce your infrastructure failures and repair costs by knowing in advance that these things are failing. Before the water is spewing out of the road, you're going to start getting some of these signals from the IoT that, hey, this could potentially be a problem, and you need to go and maybe inspect or look and see what's happening here. So using that real-time performance data to support your business and risk assessment, you can make informed decisions, prioritize repair activities in high-risk areas, and ease your regulatory compliance efforts ultimately using a package that is all-in-one and one solution, if you will. And so with that, I'm going to turn it back over to Jeff, and thank you for your time today.
Thanks a bunch, Brent. That was a great summation. Appreciate it. So how do you get started? So some of you on the call here today may be existing Cityworks and as well as Trimble Water or Telog customers. And of course, any of the applications that I've described today in our hardware products, of course, you can buy them from your local representative, and that would be Duncan-Parnell here in the Southeast. But we also have some special purchasing programs that I'd like to highlight. One is our trade-up program. This is where you can trade in your existing Trimble Water Telog products that might be, a couple of years old, that might not have the latest and greatest bells and whistles to it. You can trade those in, and we can provide a special discount for you. But we also can take trade-ins of any wireless remote monitoring device, even if it's not made by Trimble or Telog. So if you have any devices that are collecting dust, or if they're not meeting your need, or if there's an application that you want to be able to marry and mash up with the new Cityworks capabilities, you can trade those in. And so once again, that is trading in existing Trimble Telog wireless devices to get the latest models, or any existing products that you may have that do that, where you want to be able to take advantage of Trimble Unity and the system of action with Cityworks. We also have a new product or a service. It's called our RMS SaaS, or Remote Monitoring Solutions as a Service. This is where Trimble maintains ownership and maintenance of all of the different hardware that we have, and we provide it to you as a subscription. And this is a service that can be provided over a 3 to 5 year term. And the real focus here is being able to make a purchase instead of as a capital expenditure, but more as an operational expenditure, because this is a service. Now, the equipment remains owned by Trimble, and we make sure that it's maintained, and that if there's calibrations that are needed, anything related to that, we make sure that you always have the operational equipment. So we pretty much take the risk out of your hands and into our hands, and we provide that to you. And in addition to providing the hardware for you, we also provide access to the Trimble Unity remote monitoring subscription that we've shown today. So that's how you would access it, and then you would ultimately be able to connect that to your Cityworks if you have that. Also, we provide some consulting services that we have a monthly health check is what we call it, and we have a meeting with you and consult with you of how all of the devices are behaving, if they're operating correctly, if you need help being able to figure out how to configure your recorders to be able to capture the data that you need. So, but this is a service, and we sell this as a contract that operates underneath a 3 or 5 year term. This PowerPoint will be shared with you, and you're able to go to our website to be able to see more information about the RMS SaaS tool, as well as our training program. And then before we take some questions and answers, I'd like to just let everybody know that there is a webinar that's coming up in conjunction with Duncan-Parnell in York, as well as my counterpart on the gas side of things with Trimble, Mark Fiorita. They're going to be leading a similar presentation to show you applications that are related to natural gas. So that will be coming up, and there's the way to be able to join that particular webinar. So with that, we have a couple of minutes left, and if York, if there's been any questions, we can answer those now. And if we don't get to your question, we'll definitely respond to you via email.
Okay, great. Thanks to both of you. Brent, one person was asking when you started speaking about the asset management, and their clarification they would like to know is, will it work with vertical assets also?
You bet. Yeah, we have a lot of clients that use our system in treatment plants and pump stations, and also now that Esri has the indoors application, we also work with indoors for vertical assets. So if you are so inclined to go to that level of GIS, we can definitely do that with you as well.
Okay, great. Thank you. I don't see any more questions right now in the chat session, but for those of you that are participating today, feel free to unmute yourself, and you're welcome to ask questions either of Jeff or of Brent. All right, well, I don't see any more questions popping in nor people unmuting themselves, but thank you very much both to you and Jeff and Brent today for your presentations. I think it's a lot of good, helpful information. And as a reminder about what I mentioned earlier, we will be sending out a recording of this, so you'll have that for your reference, and you're welcome to pass along the recording to those that you might think would take advantage of this information. But thank you all very much.